rises to the top. Conduction, which is based on density. Density is mass over volume. So as you know, as we heat something up, it expands. It becomes lighter than its surroundings, and it's buoyed to the top. That's convection. Conduction is when two things hit together. Bam! And we transfer. You can hear me right now because the particles that are leaving my mouth are hitting the particles in the air, and they end up hitting your eardrum, and you can hear me because of conduction. And the other is radiation, which we'll talk about throughout this. I want you to look for those three things. That is the only way that energy can be transferred, is by conduction, convection, and radiation. This is a Jacob's ladder that you're watching here. And this Jacob's ladder is, it takes 50,000 volts to move electrons an inch as they jump across. And so this is pretty intense. I can take this, I can hold it down here, and I can, Panic, we're in trouble. These are my notes for what I'm supposed to do next. How we see is that on our retina, we have cones and rods. I think I've got a slide for the cones and rods on our retina. Now, the rods are see light and dark, but the cones give us color. And so when we look at different colors, of course, like my orange shirt. What color is my orange shirt? Orange. No.
It's more of a shirt.
It's every color but orange, right? Because orange is reflecting off of me, and you're receiving the orange more than any other. So, and here's what's great. Our eyes use primary colors. What are the primary colors? I heard red, blue, yellow, and green. Wait, we have a problem here. And the problem is that when we talk about the primary colors of visible light, we're talking about red, green, and blue. Now the reason they're primary colors is because we can mix these three colors together and get all the different colors of the rainbow. You saw the Roy G. Biv up there, but you can think of all the blues that you can see. You know, thousands of different shades of blue. And the only difference is a small difference in wavelength, about 10 to the minus 10 meters. Really small difference, and your eyes can distinguish between them. It's amazing to me that we can see these different colors. So go home tonight and get a little water and throw it on your TV when you pass this. You can say your science teacher told me that. A little bit, just a little bit. Sprinkle it on the surface, and what you'll see is you will see the red, green, and blue magnified in each one of those little drops on your TV. Now, so again, we can make all the different colors from these three colors, but we cannot make red, green, or blue from any of the other colors. That makes it a primary color. And of course, red, green, and yellow are the primary colors for pigments you are parting. Okay? Now, what I'd like to do is I'd like to show you a demonstration where we take yellow. I have chemical light sticks. Yellow and blue and red, and I'm going to ask Miss Pettit to help with this, and she's going to spin these around, and we're going to look to see how close we can get to white light, because when we add all three together, we get white light. Before I do that, I'm going to show you alternating current. This is an amazing little demo. It's the first time that I ever saw alternating current, and so what I've got is a light-emitting diode. I used to say this is the light of the future. Now it's here today. And this light-emitting diode has both red and green lights on it. So somewhere there is a generator spinning around a coil of wires in a magnetic field. And as that generator spins, when it goes halfway around, it moves electrons one way. That'll show up as a red light here. Then the electrons stop and they move back the other way for the other half of the motion through the flux of the magnets. And then that'll show up as yellow. So we've got red and yellow or red and green. And so what you'll see is you'll see these alternate back and forth as the electrons go back and forth. How far do they go? It depends on the size of the generator. If the generator is maybe 5 feet in diameter, that means the electrons will go about 6 or 7 feet and come back and go the other way. Well, light is emitted when electrons change speed. So if an electron is traveling at a constant speed or it's stopped, it won't emit any light. So what happens, and what you're going to see is you're going to see a green, and then you're going to see a blank space. That's where the electron stops and changes direction. So if I could get the lights down, I'll show you guys, and maybe some AC/DC music would be cool, huh? I'll show you guys alternating current. And you can see we've got the red space, green space, red space, green space. There it is. This is a Tesla coil, and here's Tesla sitting down next to a Tesla coil. He's smiling because he knows he's not grounded. And I'm not grounded either, but I can...
Oh my God!
But the frequency is so high that it travels on the surface of my skin, and so it's not so dangerous. And there are 4 phases of matter: solids, liquids, gases, plasma. Now there's another one, but I don't know it. So 4 phases of matter. Okay? What I have with my Tesla coil, I'm able to take this regular light bulb, and I've just got a metal piece on the bottom, and what I'm going to do is I'm going to create, within this light bulb, the 4th phase of matter. Because if I send enough current in here, as the lights go down, what will happen is you'll see the electrons cannot... Here's what we're going to do. Edison said it was scary, he developed the electric chair, and what Tesla said was, no, I can light a light bulb in somebody's mouth using all the
electricity.
Actually, we put some alcohol in it, so it's clean. So if you would mind, in liquid lipstick, you get a good light weapon action. And if we can, go ahead and hold it and hold it.
Oh my God! Miller!
As long as you don't let go, you will never feel it. Okay, if you let go, it's
Don't
okay?
do not let
go. Lights down, all the lights off. There's a light over there. Can you get that off? Let's see. Here we go. Thank you. Here we go. Ready? Hey! So, I'm going to run out of this. Listen, science is everywhere. It's look around. Remember the things that you learned today. Thanks for being here. You guys are a great